Alright, so lesson 24B is complex numbers. So a complex number is the sum or difference of a real number and an imaginary number. Because 5 is a real number and 2i is a pure imaginary number, they are not like terms and cannot be combined. And this type of expression is called a complex number. Okay? So standard form of a complex number, is known as a plus bi. Where a represents the real number portion and b represents the pure imaginary portion, and b represents the coefficient of the imaginary. So we're going to talk about adding and subtracting complex numbers, and your final answers need to be in the form a plus bi. So the first thing you do is see how they're addition, so I don't have to worry about distributing a -1. I can just bring everything down. And then I can just combine like terms, so you treat I like it's x. So what's -11 plus 9? Good, -2. So my answer here is -2 plus 5i. And then for this one over here, I have to distribute the -1 onto those two terms because it's subtraction. So this becomes 5 minus, yes, the sheets. Oh, you didn't get a homework sheet. My bad. You're welcome. So this becomes, we bring down the first parenthesis, and then I distribute a negative, so this becomes -2, sorry, I was confused for a second, -2 minus 6i. Now we just combine like terms, so what's 7 minus 2? And then what's -2 minus 6? Good, -8i. That would be your final answer, and it's in the form a plus bi. Now for this one, this is going to be 4 plus I plus 7 minus 5i. So 7 plus 4 is 11, and then I minus 5i is -4i. Good. And this one is, we're going to have to distribute a -1 here. So that's going to become 6i minus 14 plus I. And then I'm just going to drop the parentheses here because it's addition. And then I'm just going to combine like terms. So 6i plus I is, good, 7i minus 3i is 4i. And I'm going to put it on this side because I want it to be in standard form. Complex standard form. And now I'm going to add the numbers together. So I dealt with all of these. So what's -14 plus 5? Good, so I have -9 plus 4i. Any questions about this? Alright. So now we're going to try multiplying complex numbers. So you're basically using the distributive property here. Oops, I'm in the highlighter. So I distribute. This is going to give me 16i minus 6i squared. Now, you can do more with this because we know I squared is equal to what? -1. So we get 16i minus 6 times -1, which -6 times -1 is 6. So we get 16i plus 6, but we have to write it into a plus bi form, which means it's 6 plus 16i. Now, yes?
So if it's just 16i, you don't have to turn the I into like a number, right?
No, we can't here because I to the first power, there is no equivalent for that. You just have to leave it as I. Over here, we're going to have to use FOIL. You guys remember FOIL? First, outer, inner, last. So we're going to do first times first, which is negative 10. Good, negative 6i. Positive 20i, yeah. Positive 12i squared. So I just did FOIL first times first, outer times outer, and inner times inner. And now I can combine like terms. So in the middle I have like terms, right? So that's negative 10. That would be plus 14i, right? Plus 12i squared. So I combine like terms in the middle, and then I can do something with the 12i squared. Yeah, so I squared becomes negative 1, and negative 1 times 12 is negative 12. So this becomes a negative 12. And then what's negative 10 minus 12? Yeah, negative 22 plus 14i. And then we'll try this one over here. So first times first, that's 25. Bless you. Outer times outer, that's plus 20i. Inner times inner is minus 20i. And last times last would be negative 16i squared. What do you notice happens to the two middle terms? They cancel, and I'm left with 25 minus 16i squared. What is I squared again? So that becomes a positive 16. So 25 plus 16 is 41. So your answer here is technically 41, which is correct, but it wants our answer in a plus bi form. So how you would have to write this if they wanted that form would be 41 plus 0i, which is weird, but that's the right form because you have to write it in complex form. You have to put 0 as your b. Any questions so far? Alright, now we're going to use the distributive property again, so I'll go through these with you guys. This becomes 2i minus 10i squared. Yeah. This becomes 2i plus 10, and write that in standard form. That becomes 10 plus 2i. Now, if you have a binomial squared, you have to write it as two binomials and use FOIL. So first times first is 36. Outer times outer is negative 12i. Inner times inner is negative 12i plus 4i squared. That becomes 36 minus 24i minus 4, because this becomes a negative 1. Negative 1 times 4 is negative 4. And then 36 minus 4 is 32. And that would be your final answer.
Wait, so how'd you get from 4i squared to negative 4?
Sure, so this right here is 4 times negative 1, which is negative 4, because I squared is negative 1. And then lastly, I'm just going to do this one quickly because it's a U-try. So this is 64 minus 8i plus 8i minus I squared. These cancel. I'm left with 64 minus negative 1, which becomes plus, so this is just 65. And if we have to technically write it in standard form, that's 65 plus 0i. Any questions so far? Okay.
Can I just copy real quick?
Yeah. Alright, moving on. So, solve equations with pure and imaginary solutions. So, easiest way to do this kind of question is to get the number to one side. So this becomes 2x squared is equal to negative 32. And then how can I get the x alone on the left? Good. The x squared alone I can divide by 2. That's going to give me x squared is equal to negative 16. Now, like when you solve Pythagorean theorem, you have to take the what of both sides? Square root. And this becomes x is equal to plus or minus square root of negative 16, right? Now, anytime you take the square root of something, we do a positive and negative version of the solution. With Pythagorean theorem, we don't do that because we're doing measurements, so there's no negative. But that's technically what you always do when you take the square root and are solving for something. And I'll show you why at the end, because technically you're going to have two answers that will, if you can plug in for x, will work for the solution. So here, what is negative 16, square root of negative 16? How do I rewrite that?
Negative 4.
Like this, remember? Yeah. And then this becomes 4i. Sorry, what did I do? Yeah, this becomes 4i. And that's plus or minus 4i is equal to x. So the two solutions for x are x equals negative 4i and x equals 4i. And if you want to check your work, you can plug that into the equation and see if it works out. And I will show you that before we move on. So I'm going to plug in to show you. So that's going to be 2 times negative 4i squared plus 32 is equal to 0. Well, this becomes 2 times 16i squared plus 32. I squared is negative 1, so this becomes 2 times negative 16 plus 32 is equal to 0, which becomes negative 32 plus 32 equals 0. Is that true? And then you could also try it with the positive, and it'll give you the same answer. That's why you have two answers here. And then this one, we'll subtract 4 on both sides. We get x squared is equal to negative 4. We take the square root of both sides. That gives me x equals plus or minus the square root of negative 4, which I know to be square root of 4 times square root of negative 1, which I know to be plus or minus 2i, which means my two solutions are x equals 2i and x equals negative 2i. Wait, are you confused? Oh, sure. So you remember in the last lesson how whenever you have a negative square root, you have to separate it into the positive square root and the negative square root of negative 1? The square root of negative 1 we learned about in the first lesson is equal to I. Okay. You guys good to move on? Alright, let's move on. So find the value of x and y that make each statement true. Okay, so let's try to solve this the best we can. Equation. equating complex numbers, find the value of x and y that make each statement true. So over here we can factor out what? 2. So that'll give me 2 times 5 plus yi is equal to 5x plus 6i. Yeah, what's up?
So did you just turn where'd the y come from in the parentheses?
Sure, so I just factored out a 2, which means I just divided this and this by 2, and then whenever you factor out, you bring that number on the outside. So if you were to do the distributive property, you'd end up back with what we have. Does that make sense? So in this case, we want to know what values would make this true. So now that I factored out the 2, I'm looking at it, and I want this to equal this, right? So if I want 6i to equal 2yi, what could the y be here to equal that? 3. And if I want 5x to be equal to 10, what could my x be? 2. So sometimes factoring out can help you visualize it, but sometimes it's just easier to look at it and see. So in this case, if I want 5x to be equal to 10, that means x would have to be 2. And over here, if I want 6i to be equal to 2yi, well, y would have to be 3. You guys want to try this one on your own? I figured not. Let's do it together, okay. So let me look at it real quick. Okay. Some of these can be tricky. You have to like think about them. So in this case, I can simplify this, but not really because this is multiplied by the I. Well, I can take the complex part and the non-complex part and set them equal to each other. So if I set this piece equal to this piece over here, that gives me 3 plus 2y is equal to y minus 6. And then I just want to solve for y, so I add 6 to both sides. That gives me 9 plus 2y equals y. I subtract 2y on both sides, which gives me 9 is equal to negative y. Divide both sides by a negative 1, which gives me y is equal to negative 9. So once I set the imaginary parts equal to each other, I can then set the non-imaginary parts equal to each other. Okay? So whatever is being multiplied by the I, you can set those two pieces equal to solve for that variable. And whatever is the non-imaginary part, you can set that piece equal to each other.
So if you get that answer, that's just the answer for the problem.
Yes. So then over here, I could add 2 to both sides. That gives me 5x plus 3 is equal to 2x. I subtract 5x on both sides, which gives me 3 is equal to negative 3x, which means x is equal to negative 1. So when you get to these kind of problems, the best suggestion I have, sometimes you can factor things out, which will help you see it better, but sometimes it's not necessary. You can set the imaginary pieces equal to each other and solve for y, but you don't have to leave the I. You just take the 6 and the 2y and set it equal, and then you take the non-imaginary parts, set them equal to each other. Like we did over here, anything imaginary, set this piece equal to the other imaginary piece, set the non-imaginary equal to the non-imaginary, and solve for the variable. Make sense? Okay. So your guys' homework for this lesson will be due on Tuesday. You have